Hello. So we are back, and this time we have a customer joke. A nice MacBook Air. What this MacBook Air is doing, basically nothing. We have no green light, we have no orange light, it's taking no current at all. What the customer is saying, MacBook A1466 not powering on. On inspection of the logic board, I spot little bit of corrosion underneath. See the picture. We're gonna see the picture. I cleaned it with alcohol, but didn't help. Still not powering on. No fan spin. I don't have a microscope or hot air, so please, yeah, check with the multimeter. Checked with the multimeter on the power supplies. Main 8.5 and 3.3 are present. MagSafe LED shows green. I guess this is coming from 3.3 volts. Other power supplies are 0 volts. You know what? I can't see any light on the charger, yeah. And this is a proper, yeah. I should have green light here. It's an adapter from USB-C. Very useful. Actually, I can see the current which is going on the MacBook. So should be green light there. The picture. Let's see the picture. Desktop. So that's the picture. Yeah, we can see there some liquid damage next to the SMC chip. Yeah, but the customer cleaned it and it's still not working. Okay? So I will say let's try and fix it. But let's agree first, yeah? We have no green light, yeah? No green light. Okay, let's open quickly. Okay, let's take out the back cover. And everything is plugged in, everything looks good. Let's plug the charger. Let's grab the multimeter. It's taking like 20 milliamps, something like that. Let's zoom a little bit. Okay. Any voltage, we have a fuse here, and we have 8.1 volts, you can see on the screen. We don't have the green light, so I suppose we have to take the board out and check on the other side where was the damage. Okay, so we took the board out. Let's try to have a look under the microscope. Let's see what kind of damage we have here. I believe here we have missing components, right? Let me get rid of the reflections. I mean, it's not only the damage, are missing components here. Here and here. Okay. Here we can clearly see this track is gone. I mean, this one from here. You can see the track here. Okay. So let's try and clean those and try to fix them. So you see, wherever you see this kind of damage, yeah, those are power rails. Yes, I mean, here is power. That's the reason why it's oxidated, yeah, because it's power here. Power with water, not very great. Yeah. Any other liquid damage spots? Yeah, not only there, yeah? Not only there, check here. Oh, you want liquid damage anywhere but not here, yeah? Not on the oscillator, not here. Anywhere else but not here. I mean, a drop of water here can make this dead. Or it is good. It is good. And this one has to go here. Yeah, it is good. Okay, looks good. Let's replace the chip. Now we do have to solder that resistor back. And the pads are good. Perfect. Now let's check the track to see if it's good. So the track has to be from here. And it's not good. Okay. Let's use a wire. Perfect, right? But tell me it's perfect or not. Now let's clean it. Okay, the most important part from here, okay, that's bad. Because this, it's a carbo resistor. And we need to know where it's going. Okay, this is going here clearly, yeah? Where this is going? Huh? Where this is going? Anyone knows? I think we can get a board view, but this is simple. This is 3.4 volts, right? So should be somewhere. I found it, yeah? So this track is going. So we need a wire. We need that wire from here to here. Yeah, so we need that wire from here to here. Yeah. Yeah, here. Okay, good. Now let's do it. solder iron. Let's grab some flux. Yeah, rosin flux is better. A little bit of rosin here. So that's ground, that's plus. So plus is coming here, down, and here up. Yeah? So I don't think we did anything wrong here. But let's check to be sure. Don't tell me the SMC is shorted. Don't tell me that. Don't tell me that. From here is short. From here is short. Okay, that looks bad. So you remember here, from here to here was a capacitor. Yeah. And on my other board, let's see, my other board. Ah, sorry. Here it is a capacitor, okay. So the plus is only from here to here. Yeah, that's the plus. But where is going? Because this truck is gone. My truck is gone. So where is going this thingy? Okay, I think I found it. I think I found it. 1 second. Here. Here. And here. Yeah? So we are coming with our wire here, exactly there, yeah? Okay, let's grab the other board. Because we have to jump over this track, yeah? So let me unsolder this one, the old one. Let me get this out. We need some rosin. We need another wire. Perfect, yeah? And we have to come with the wire exactly here. Exactly here. Something like that. Something like that. Okay, so I took off the board view the schematic and it's looking bad. So our fault was this L coil carbon resistor, whatever. So here is plus. So what we did, we route the track from here, the 5 volts, yeah, here to those capacitors. But because I thought, you know what, this point is going here, but it's no, it's going straight under the SMC. So that's my issue right now. I have no way how can I take this because both are rusted. I can't do it. I have to take it from there. Or maybe somewhere else on the other side of the board. Can be. No, it's not. So there is no way how can I reach the SMC because here everything is rusty, yeah? I mean, we don't have pads anymore. Yeah, here is a capacitor and here is another capacitor. So what's the solution then? What you will do on a case like this? Because we have to reach this pin PP3V3S5. Okay, this is the power rail which we have to supply voltage. So what is the way to go in this case? I mean, okay, we supply voltage from here to those capacitors, but how can I supply voltage to the SMC straight on that pin? Because both are rusted. We can try, yeah? Let's go and try. Yeah, let's try to dig in. What do you think? Can we dig in? So where we can find that track? Where is it? Must be there, right? Must be there exactly on the coil pin. But it's rusty. I can see it's green. Right? Must be here. So here is nothing, just a track. Here is nothing. But here. Nothing. So we have to start digging in like a rabbit and try to find the track. It's not here. Oh, wait. I seen something on the bottom. Wait. I swear I seen something. Yeah. 0.7. You think that's our pin? Okay, so that is the track. You see that on the bottom? Yeah, that's the one. That's the one we are looking for. You can see it? Yeah, that's the one. Okay, let's try to solder a wire. So how is it? We done a good job. Let's check with the ground. Let's see. Yeah, you can see on the screen 0.5. So that's okay. But we need to clean up and try to use some UV gel. Yeah, but this is this is kind of crazy job, huh? Insane. I want to solder that wire exactly on the same point, yeah? I want to solder that wire there. Yeah, I know, any flux, I know. Perfect, good enough. Now let's try and clean it. Actually, you know what? We should test it first to see if it's working. Right? You know what? It's still not working. I mean, it's taking like 50 milliamps. What's that? So we are here after like 3 hours. 3 hours trying to figure out what's wrong with this board. The problem, yeah? I mean, I'll retake again because like 3 hours we rebuild the truck here to the SMC. Everything seems okay. Every power supply seems to be fine. I mean, I can't see anything wrong. Now the problem, the power good is missing. Yeah, the power good signal. I mean, it's coming on for a second, goes off. Now, finally, I figured it out. My problem. One second, and I figured it out, because I run out of options. I mean, like I have like 35 milliamps is drawing power. So I checked the Lewis wiki, yeah, and here he's saying like that, yeah. Look what he's saying: 2324 milliamps draw. Okay, many of these, but this one, yeah, is saying the PM SLP S4 missing, and indeed I checked and it's missing. Now after that I removed what he's saying. 1 second. R8111, and after I removed this I got like the power go signal fine, the board is starting, the power supply are starting. I don't understand why he is saying, no, I don't have corrosion around the RAM, yeah? Why he is saying it's most likely at that CPU. I don't understand why he's saying that. I mean, just because he's saying it can be at that CPU, it doesn't make me feel good. I mean, originally, if I put back that resistor, what is happening? I can simulate. It's not even point putting the resistor. I can simulate with the power supply. That 3.3, yeah. Let's try it. Let's do it together. So we have 3.2 on the power supply, and I'll simulate back that resistor, yeah. Let me see so you can see. Maybe here are good people with the MacBooks and they can give me an idea. Here, on this test point. So check here, yeah? You see? You seen that? So it's staying basically, so right now at like 50 milliamps. If I unplug it, I have like 24. So it's taking like 25 milliamps, yeah? Check here, yeah? It's going to 0.3, then immediately it's going down back to 25 milliamps actually. Now, what is the difference? Yeah, because in the moment when the power is going up to like 300 milliamps, check there, 300 milliamps, everything starts on this board, including the CPU V-core power supplies. But if I remove that resistor like now it's removed, yeah? So without that resistor, we are, the board is taking 180 milliamps. Every power supply is on, apart from the CPU. Now, the problem here is, this is the resistor. The problem here is DDR reg enable, okay? So we remove these resistors, R8111. So that means the DDR reg enable is not present anymore. I mean, I don't understand why the present of this signal, yeah? If this signal is present, DDR reg enable, why that means it's at that CPU. Also, why if I connect this resistor, the CPU V-core is like present for 1 second and goes off. Now, being a shorted CPU, can be I checked both CPUs. I mean, from this board and my spare board, and indeed, it's a difference. I mean, I'm not sure if it's a different CPU or what. So here we have 10 ohms. You can see 10 ohms, yeah? And on this one, we have 15 ohms. So 15 on a coil, 15 on the other coil, because those coils are together. But this one, 10 ohms. I mean, usually the resistance, the internal resistance of the CPU is getting lower if the CPU is better. I mean, it's taking more power. But not sure if indeed here it's a shorted CPU or not. Anyway, I got stuck, you know, like, I don't know what to check. If you are good with MacBooks, tell me why that signal, this signal in the first place is disabling the CPU vCore power supply, the DDR reg enable. Yeah, so that I can see. But without that signal, my other signal, my PMSLPS4 is present. Yeah. If I solder the resistor back, that signal is missing. So what's the catch? What I'm missing here? Because I get stuck. I'm like from 3 hours here trying to figure it out. And on a point, you know, I said, let's open this page and check. And they're saying it's most likely the CPU. If you have experience of this board, tell me if 10 ohms on the CPU is okay. I mean, I don't know what to do. I'm like, I know this board has a dead SMC. Yeah, so I cannot fix this board and give the customer this one. But I spent so much time on this one just because you see how little was the water, the liquid damage? So we fixed the SMC. Clearly, the SMC is fixed, yeah, and it's good. It's working. We fixed this, which is related with the Bluetooth. You remember here was a little bit of liquid damage. Here I replace every part, yeah, on the CPU oscillator. Yeah, I replace everything, including the quartz, the crystal. Yeah, I replace everything. So you know when you work so long, you just want to get the job done. I mean, I'm kind of, you know, it's not that busy and I have time to spend. But I'm on a point, actually nothing helped me, like even the schematic, you know, if I put the resistor back and you see the board is, everything is coming on from like 1 second, then goes off. And it's, wow, where is the problem? I mean, everything, including the power good, including the vCore, everything for 1 second, 1 second. Then now after I remove that resistor, which they are saying, remove that resistor and see if the signal, the S4 is present, it is present. See you on the next one. Just leave me a comment. Maybe you know why they are saying the CPU is that. And why my CPU indeed is different. I mean, 10 ohms versus 15 ohms. It's kind of a big difference. See you on the next one. Bye.